I think most people see the inherent value in discovery, for its own sake, when it comes to the natural world and physical science and things like that. Like if someone discovered a new planet, I don't think there's very many people who's going to say, oh, what's the point of that? Why do we need to know that? I think people just, are going to value that discovery for its own sake. But that attitude is much more rare when it comes to math. A lot of people ask, what's the point, of this, that, or the other math? And I think there are two reasons for that. The first is that, the discoveries of math are intangible. Okay? They're abstract. So they're harder to relate to. And the second reason kind of explains why. It's because of how math is viewed and taught, for the most part. So the way math is taught, unless you actually become a math major and, do some higher level math stuff, you're kind of brought along as a spectator. Let me explain what I mean a little better. The way I view math is the study of logical consequence. So the way math is done is you start with a set of axioms, which are kind of like rules to a game. And when you do math, you're seeing the consequences of those axioms. Now, the oldest example I know of this is from Euclid, his Elements, his Euclidean geometry. He starts off with his postulates, which are axioms, and from there he goes on to find results. I think of it sort of as like a tree. So by coming up with the axioms, you're kind of planting a seed, and then finding the resulting consequences is sort of like climbing the tree that grows from the seed. So when Euclid came up with his axioms, he planted a seed, and something like the Pythagorean theorem is one of the branches of the tree, and discovering it and proving it is sort of like climbing the tree. So when you're learning math, in grade school and most of college, you're brought along as a spectator. You're not climbing the tree. Look at the exercises of like a Calculus 1 book or a differential equations book. What are they? They're always commands. They're always solve this for x, or take the integral of this. They're yelling at you to do things. You're not being asked to climb the tree. You're a spectator. On the other hand, if you look at an undergraduate math major taking his first topology class, he might be asked to prove that the image of a compact set is compact, or whatever. The point is, he's brought along. He's participating. He's being asked to climb the tree. But most people never get to do that. Most people are brought along as spectators, and I think that's a huge problem, and why no one, majors in math, because they don't know what it is. Now, going back to the intangible thing, logical consequence and the rules of logic and the idea of reason itself, okay, it's either an inherent part of our universe or it isn't. If it is an inherent part of our universe, in the same way that laws of motion are, then studying that is inherently valuable. So I think of physics, for example, as being sort of the hardware of the universe, dealing with the tangible. And math and logic, deduction, is sort of like the software, like it's intangible, but it's still part of our reality. It's also possible that deduction, reason aren't an inherent part of our universe, but that it sort of transcends it. And in that case, it's maybe even more valuable to study and to learn about. So if that's the case, then by applying reason and deduction and climbing the trees, planted from the seeds of axioms, we're sort of reaching through, the cosmos. I sound so corny right now, but really that's how I view it. we're sort of reaching beyond, you know, physical reality and touching something that's higher, you know, something deeper. So what's the point of math? I guess that's the point of math.